21, Alyssa and Gabriel play the following game. Alyssa rolls a die. If she rolls a 1, 2, or 3, Gabriel gives Alyssa $3. If Alyssa rolls a 4 or 5, Gabriel gives Alyssa $2. However, if Alyssa rolls a 6, she gives Gabriel $14. So determine Alyssa's expectation. So Alyssa could win. Well, wait, no. What could happen to Alyssa? So she rolls a die. If she rolls a 1, 2, or 3, Gabriel gives her $3. So she could come out $3 ahead if she spins a 1, 2, or 3. So if she rolls a 1, 2, or 3, the probability of that, there are 6 numbers you can possibly roll on a die. So 3 out of 6. So she'll get $3 about half of the time. And she could also roll a 4 or 5. And if she does that, Gabriel gives Alyssa $2. So she'll come out +2. And the probability of rolling a 4 or 5 is 2 out of 6. Last possibility, she could roll a 6, and then she would give Gabriel $14. So she would have to give him $14, so we're going to make that negative. And one number there, so 1 out of 6 chance that she'll have to give him $14. So always check to make sure we have all the possibilities. It looks like we do, because there's only 6 possibilities on a die, right? 1, 2, 3, 4, 5, 6. We've accounted for them all. 3 6 plus 2 6 plus 1 6 is 6 6. So it's looking good. We have all the possibilities accounted for. So we're just going to multiply x times p of x, and then for all of them, and then add them up like we've been doing. So let's see. So 3 times 3 6 is 9 6. 2 times 2 6 is 4 6. Negative 14, I won't forget the negative this time, is negative 14 6. Add those all up. 9 plus 4 is 13. Minus 14 is negative 1 6. So negative 1 6 is about negative point. It's 1 divided by 6. So if I do 1 divided by 6, I get 1 6 6 6 7. So it looks like she's going to lose about 17% every time she plays this game. So let's check that. 21. Yeah. So if she's going to lose, this is Alyssa's expected value. So if Alyssa's going to lose 17% every time she plays, if we did the same thing for Gabriel, it would make sense that he would win 17 cents every time he played. So that's Alyssa's expected value and Gabriel's expected value. Alright, so that's that one. We'll move on to 25. So for 25, we have raffle tickets. 500 raffle tickets are sold for $2 each. One prize of $400 is to be awarded. This guy purchases one ticket, determine his expected value. So, let's see. So 2 possibilities. Either he could win $400, or he could lose the cost of the ticket, right? So he could lose. Now we have to be a little careful here because he had to pay for the ticket. So his profit, if he wins, he gets $400, but 2 of those bucks were for the ticket. So his profit would be $398. So he could either win and profit $398, or he could lose and lose the $2 worth of the ticket. And so those are our expected outcomes. And the probability of each outcome, there are 500 raffle tickets and only one winning number. So 1 out of 500 is his probability of winning, which means that 499 out of 500 is his probability of losing. Add those up, they add to 100%, 500 out of 500. Those are the only possibilities. So then we're just going to do our x times p of x. And so I'm getting 398 over 500 minus, what is that? 998 out of 500, which gives us minus 700 out of 500, which is about negative 1.40. Let's see if my brain's working this morning. Negative 1.20 is what they've got. Probably just messed up somewhere. We can use a calculator. Let's see. So 499 times 2 is 998. 398 minus 998 is minus half. Sorry, minus 600 here because I can subtract. Minus 600, so that's negative 1.20. So every time he plays the lottery, he expects to lose about $1.20 on average. So that's your answer for part A. That's your expected value. And so then they want to know for part B, determine the fair price of a ticket. So a fair price would mean that you would break even if you played. So, okay, so for part 25B, they want the price of a fair ticket. So if we pretend we didn't have to pay anything at all, our two possible outcomes would be we could win a $400 prize, so come out $400 ahead. So we could come out $400 ahead, or we could lose and come out with nothing. And the probability of winning is 1 out of 500. So the probability of losing would be 499 out of 500, because those have to add to 1. So if we do our x times p of x, we get 400 over 500 and 0 there, because 0 times that is just 0. And your expected value would just be adding those up. 400 out of 500, so 0.8, so 80 cents to play. And so if you didn't have to pay anything, your expected value would be 80 cents. So to make it a fair game, you'd have to pay 80 cents. So that is the price of a fair ticket. So that was 25B. Yeah, looks good.